So see, let us consider one random binary sequence is being given to this binary frequency shift modulator. Then instead of going through this mathematical treatment, graphically we will try to see how that signal will look like, or how that desired envelope is being produced with the help of these two channels, upper and lower channel. So any random data we can consider. If suppose the data is like this 1 0 1 1 0 1, which consists of 1 2 3 4 5 and 6. So total there are 6 bits we used to have within this proposed information bearing signal, which we are interested to transmit with the help of this binary phase shifting modulator, right? So initially this symbol sequence will appear across this upper level shifter as it is, right? So the desired symbol sequence is what here, 1 0 1 1 0 1, right? So as I told you earlier, this level shifter will accept either binary 1 or binary 0, and it will convert it into desired signal interpretation with the help of high or with the help of low frequency. If binary 1 is being given, it is being converted into certain amplitude carrier signal. If binary signal is 0, so the output of level shifter is being also 0 for upper as well as lower channel, right? Now for this lower channel, this whole sequence is being passed through this inverter, right? So once it is being passed through this inverter, so here I will write this desired symbol sequence. It is 1 0 1 1 0 1, right? Now before it is being given to the level shifter belongs to the lower channel, it will get converted in its complement form. So it will become what, 0 1 0 0 1 0, right? Then each and every bit is being given to this level shifter during that signaling interval, and that particular bit is being multiplied with this high frequency and the low frequency, right? So the output of this upper multiplier will be what, initially the first bit is nothing but binary 1, right? So here we will represent how that signal will look like. So which frequency is being assigned to binary 1? High frequency is being assigned. So how the output of this first multiplier will look like? Let us consider. The first bit is nothing but what? Binary 1. The second bit is 0. Third and fourth bits are again binary 1. Fifth bit is 0 and sixth bit is 0, right? So during each and every signaling interval, if suppose these two sinusoidal signals are being transmitted like this, for binary 1, right? Then for binary 0, output of level shifter is 0. Then again for 2 times we are having this binary 1, so high frequency is being multiplied with this binary 1. This is the bit duration for 1 bit, and this is the bit duration for another bit, right? So the bit number 5 is nothing but what? Again it is 0. Bit number 6 is nothing but 1. So for 0 the output of level shifter is 0, and for binary 1 high frequency is being represented with respect to t, right? So this is how the output of upper multiplier will look like. As far as the lower multiplier is concerned, so what kind of symbol sequence is being given? The lower multiplier is complementary of upper one. So the which signals are being given? 0 1 0 0 1 0. So for if it is 0, the output of level shifter is also 0. Here I will synchronize these two signals like this. So during this first signaling interval, as first bit is 0, so the output of multiplier is 0. The second bit is 1. That second bit is being multiplied with this lowest frequency, right, during this signaling interval, right? Now this is nothing but what, how binary 1 is being represented belongs to lower channel. Then for 2 times we are having 0, so this is the first one and this will be the second one. Then after that, first symbol is 0, then 1 is being multiplied with this lowest frequency. For 2 times we are having 0. Then for single time we used to have 1. So the same cycle is being multiplied but with lowest frequency, right? Then last bit is nothing but what? 0, right? So this is 1, this is 0, this is 1, this is 2 times 0, this is 1, and this is 0. Here 1 0 1 1 0 1, right? Now this is how these upper and lower channel will try to generate the desired signals out of it with the help of high frequency and low frequency. So the last block is nothing but what? It is the adder, or we can say that the signal combiner. When these two signals are being combined with each other during each and every signaling interval, so how that signal will look like? During that first signaling interval, here first bit is 0, here first bit is 1, represented with this binary, represented with this high frequency. So how it will look like? In this way, which consists of two cycles with high frequency. Now, as far as the second bit is concerned, the second bit for this upper channel is 0, the second bit for this lower channel is 1. So that 1 is being represented with this low frequency, which consists of two cycles, like this, right? The third bit for this upper channel is 1. Obviously, as these two signals are complements of each other, if it is 1 then it will 0, if it is 0 then it will 1. So the third bit is 1, fourth bit is also 1. So these two bits represents these high frequencies. This is the fourth and this will be the fifth, right? Now after that, which bit we are having here? 0. And which bit here we are having here? It is 1, right? So which bit is being represented? This the bit corresponding to the lower channel with this lowest frequency is being represented like this, right? And during the last signaling interval, these two symbols are being combined with each other. This to the upper channel we are having 1, and to the lower channel we are having 0. So 1 plus 0, it is being represented with this high frequency with respect to t, right? So this envelope can be called as a binary frequency shift keying signal, BFSK of t, where clearly, as you can see, the two identical frequencies, this is nothing but what? High frequency, this is low frequency, again this is high frequency and low high. So in this way, the desired symbol sequence, which is nothing but what? 10110, is being transmitted with the help of BPFSK modulator, which consists of these two identical channels, upper and lower, which are being tuned to the high frequency and low frequency. So in this way it is being represented. So the remaining part is nothing but what? How the symbols are being demodulated from this given envelope. So as I told you earlier, in case of digital modulation, there are two types of detectors we are having. One is nothing but coherent and another is nothing but what? Non-coherent detector. So let us quickly go through the coherent and non-coherent detector in case of binary frequency shift keying technique. Okay, so this is how the coherent and non-coherent detector will look like in case of binary frequency shift keying. Now already we had discussed with the help of these two significant frequencies, high and low frequency, how the desired envelope is being generated. Once that envelope is being generated, then in that third approach, our area of interest is to extract the desired information bearing symbol sequence, which was given by or which was emitted by a modulator towards the demodulator. That is the main objective behind this detection, and that objective is to be completed with the help of these two coherent as well as non-coherent detector. So first of all, we need to understand the working difference in case of this coherent and non-coherent detector. So coherence means coherent detector is nothing but what? Which adopts the same carrier frequency which was used by that binary frequency shift keying modulator or binary frequency shift keying generator. The same carrier frequency is being utilized by this binary phase shift keying demodulator, right? This upper one is being tuned to higher frequency and the lower multiplier is being tuned to lower frequency, belongs to binary 0, right? So one more time, these two identical channels we used to have belongs to upper and lower frequency, which consist of this multiplier along with this integrator. So basically what this integrator will try to do, it will try to integrate the desired symbol sequence which is being given by these two multipliers, right, over a single bit duration, that is nothing but what? The TB second, right? Then after that, the output of these two integrators are being added with the help of this combiner, and it is being given to this decision device, right? So finally this decision device will take the decision in terms of binary 1 or in terms of binary 0. So this upper section or the combination of this multiplier and integrator, that can be called it as a correlator. So upper correlator is being tuned to higher frequency and the lower correlator is being tuned to the lower frequency, FH and FL. Now as you can see, what this Y of t stands for, this Y of t is nothing but the output of this combiner, right? So if suppose this Y of t is greater than 0, at that time this decision device will take the decision in terms of binary 1. If this Y of t is lower than, or if the significance of this Y of t is less than this 0, so at that time this decision device will take the decision in terms of lower frequency or binary 0. If the output of this upper correlator is greater as compared to the lower correlator, so at that time Y of t equals to 1. If the output of this lower comparator or the lower correlator is greater than the upper correlator, so at that time this decision device, through which we can have a certain threshold, so it will try to compare this Y of t with its threshold value. So if Y of t is greater than this threshold, it will take the decision in terms of binary 1, or if Y of t is less than this threshold value, then it will take the decision in terms of binary 0. So this is how this coherent detector will look like, right? Now the lower one is nothing but what? The non-coherent detector, which consists of a pair of band pass filter as well as an envelope detector, right? So this band pass filter is being tuned to higher frequency and this lower band pass filter is being tuned to the lower frequency belongs to binary 0. So both these two band pass filters will try to pass the major lobe of high frequency and low frequency with minimum distortion. Then after that it is being given to the envelope detector, and the output of these two envelope detector is being given to this, that can be called it as a unipolar comparator, right? And based upon this comparison, somehow we can extract the original symbol sequence which was given to the input of this binary frequency shift keying modulator or the binary frequency shift keying generator, right? So this is how this coherent as well as non-coherent detector will perform its functioning in case of this binary frequency shift keying technique, right? So I just hope that you can understand all these things belongs to this binary frequency shift keying, which involves three different approaches: representation, generation, and this is nothing but what? Detection. Thank you.